Okay. All right, so we're going to talk about the relationship between the roots and coefficient of a polynomial. That already sounds, yeah, confusing, okay, crazy, hard, I don't know, okay, but yeah, from the moment that you read this, you say, yeah, what is going on? Okay, what happened is this. Okay, let's say we're going to do the introduction. Let's say that you have this equation, x squared plus 8x plus 7 equals 0. Okay, let's say that you have that equation. And then we are going to find the solution for that equation. Okay, so we can find the solution in many different ways. In this case, we are lucky because I think that we can factorize it. Okay, so we can find easily two numbers that when you times them together equals 7, and when you plus them together equal to 8. All right? And those numbers are 1 and 7. Okay, so I mean that this can be factored as x plus 1 and then x plus 7. And then we make that equal to 0. All right? Okay, and then from there we can say that the solution for that equation, okay, so therefore we're going to say, therefore, the solution for this equation, x equal -1 and x equal to -7. All right. And then what we are going to do, we are going to add these two solutions. I'm going to call this solution 1 and solution 2. So I'm going to call them x1 and x2, like that. x1 and x2 just to differentiate them. And then we're going to plus them. And then we're going to multiply them. Okay, so we're going to add them, and then we're going to multiply them. When you add the solution, okay, so you're going to be adding -1 and -7, so the answer is going to be -8. Can you see that? Mm-hmm. All right, -8. And when you multiply them, the answer is going to be +7. Right. Now is when I want you to open your eye and see what is going on, okay? Because I'm going to give you another example, and then you're going to see the pattern about something that is happening. Okay, so you're going to find a relation between the solution and the coefficient of the equation. Okay, the coefficient of this equation are 1, 8, and 7. Can you see that? Okay, and the solution for this equation are -1 and -7. When you add the solution, the answer is going to be the opposite to the number. Okay, so if this number is -8, then in here you're going to have +8. But in this case, can you see that this is +8? So I mean that the answer is -8. And then when you multiply the answer, then you're going to have the constant, and that is going to happen all the time. Okay, I'm going to put another equation, and then we're going to see that we have a pattern, and then I'm going to give you another equation, and then we're going to generalize. Okay? Okay, let's do another equation. And then you're going to understand what is going on. All right, let's say that you have this equation now. 3x squared plus 2x minus 5. Okay, so let's do 3x squared plus 2x, I think it was, Yeah, plus 2x minus 5. Right. Now, I want you to factor the equation. So I want you to put that into factors. So you need to find two numbers that when you times them together equal negative 15, but when you plus them together equal positive 2. Okay. Think about it and then tell me what the answer is. Positive 5 and negative 3? Yes. Okay, so that means that we can put this equation again as 3x squared plus 5x minus 3x minus 5 equal to 0. All right? And then we're going to group them in pairs as we've done previously. So we're going to have x is a factor of 3x plus 5. And then the next factor is going to be negative 1. And then we're going to have 3x plus 5 equal to 0. All right? And then from here we're going to have that x minus 1 multiplied by 3x plus 5 is equal to 0. And therefore from here we're going to have that x is equal to positive 1 and 3x plus 5 is equal to 0. So I'm going to just write the answer. So the other answer is going to be x is equal to negative 5 on 3. Okay? So from here we have x equal 1. From here we have x is equal to negative 5 on 3. All right? And again, I'm going to call the first solution x1 and the other one x2. Now we're going to plus them. Okay, so we're going to plus these two solutions. So we're going to say x1 plus x2. So you're going to plus 1 plus a negative 5 on 3. What is the answer? Negative 2 on 3. And when you times them together? It's just negative 5 over 3. Sorry? Still negative 5 over 3. Still negative 5 over 3. All right, and then we're going to look at this fraction, and we're going to see if there is any relationship between the answers and this coefficient. Now, if you look very, very carefully, when you add them together, the answer is going to be the middle term with opposite sign divided by the leading coefficient. Can you see that? So it's going to be negative that number divided by the coefficient. And when you times them together, can you see that the answer is going to be this number as is? Can you see that in here is negative 5? And in here we have negative 5. And again, divided by the leading term. Okay, so it doesn't matter, you know, what polynomial you have. Okay, so it could be a quadratic or cubic or quartic. We're still going to have some pattern. We're still going to have some relationship between the solution or roots and the coefficient. Okay, and that is what we are going to state and generalize. All right? Okay, so we're going to say in general. In general. Okay, so we're going to start with the quadratic. Okay, with the quadratic equation. We're going to say this. If, now I'm going to introduce a special name for the roots. Okay, rather than saying x1 and x2, I'm going to start talking about alpha and beta. All right? So instead of saying x1 and x2, I'm going to start talking about alpha and beta. All right? So you need to get familiar with that. Okay, so we're going to say if alpha and beta are the roots of the equation ax squared plus bx plus c equal 0. Okay, so if these two are the solution for this equation, then alpha plus beta is equal to minus b on a. So it's going to be minus this number over a. And when you multiply them, the answer is going to be c on a. Okay, and then I want you to bubble the thing, because this is something that we're going to be using from now on. And we're going to prove that this is true when we have a quadratic. We can prove easily, that it is also true when we have a cubic and a quartic, but we are not going to do that. You can see, the proof in the textbook. Okay, but let's prove that this is true for any quadratic equation. Okay, so I want you to understand this. Okay. What we are doing is finding the relationship between the coefficient of this quadratic equation with the solution. Mathematicians are very curious about everything. Okay, they start, playing around with things, and then, suddenly they discover that there is a relationship between things. Okay, somebody had probably did that long time ago, and then he discovered that there was a pattern, and then he established it, the relationship between this coefficient and the solution. Okay, but we're going to have to prove this. Okay, we're going to have to prove this. And the proof is not hard. And the reason why, because we have a formula for the quadratic equation. All right? Do you remember that if you have this equation, then we say that the solution is x equal minus b plus or minus square root of b squared minus 4ac divided by 2a. Okay, so are you familiar with that equation? All right? Okay, so can you see that in here we can see plus or minus? So that means that we can name the first one alpha and the second one beta. Okay, so we're going to say, so let alpha equal to the first solution, so the one with plus, and we're going to call beta the second solution. The solution when you choose the takeaway. Okay, so it's minus b squared minus 4ac on 2a. All right, so these are the two solutions, or the two roots of this equation, as we all know. Now, what we are going to do, we are going to plus them and see what the answer is, and then we are going to multiply them and see what the answer is. All right? Okay. So we're going to say, now, let's do the addition. So it's going to be alpha plus beta equal. All right, so if we add these two solutions, that means that we're going to be adding these two fractions, right? Now, can you see that these two fractions have the same denominator? So we have over 2a over 2a. And because they have the same denominator, then we can put them together. Okay, so that means that all what we have to do is to add the top line of this fraction together with the top line of that fraction. Now, if you look carefully, can you see that when you add this and this, the square root, they cancel each other? So that means that we're going to have only minus 2b. Okay, but if you cannot see that, okay, let's do it. So we're going to have minus b plus, I'm gonna call the square root thing, I'm gonna call that delta. Okay, just to save, notation. Okay, so we're gonna say minus b plus delta, and then minus b minus delta, and then all over 2a. I call this delta because yeah, I don't have enough space, that's all. All right, so then we can do it anyway. All right, and then
what's delta?
I'm calling delta to the square root part, all this. Okay, I did that because I don't have enough space. I just as a short notation.
I just write at the bottom. So it makes no sense.
So do you want me to say that delta is equal to this?
Yeah, that's all right. Just keep going.
All right, okay. And then can you see that these two cancel each other? Right? And then what is left on top? Minus 2b. Okay, so we're going to have minus 2b, and then all over 2a. And then when you simplify this fraction, well, the answer is going to be minus b on a. Okay, so that is equal to minus b on a. All right, so I mean that the first part is done, and it's correct. So when you add the two roots, then the answer is going to be always this number over that number with opposite sign. Okay, so that is that. Now we're going to do the multiplication. So we're going to do alpha multiplied by beta. Okay, so this time I'm going to write the whole thing. And so we're going to have minus b plus the square root of b squared minus 4ac divided by 2a, and then multiply that by minus b plus square root of b squared minus 4ac, all divided by 2a. All right. Okay, and then we're going to multiply. Yes?
Is that second one supposed to be minus the square root?
Yes, so this is minus. Thank you. Okay, and then if you look very, very carefully, can you see that the top line is the difference of two squares? So we have minus b plus the square root of that, and then minus b minus. Okay, so it's the difference of two squares. And we know that when you have the difference of two squared, you are allowed to multiply the first term by itself. So we're going to do minus b squared. What is the answer for minus b squared? B squared. All right? Okay, so we're going to continue here. So alpha multiplied by beta is going to be equal to b squared. Okay, and then we are going to multiply the square root by itself. Okay, what happens when you multiply the square root by itself?
It becomes like just itself?
Yeah, it becomes only, yeah, we get rid of the square root. Okay, so that means that we're going to have b squared minus 4ac. Okay, so it's b squared minus, and then we're going to have b squared minus 4ac. And then all that divided by 2a.
No, it would be 4a squared.
Sorry?
You're going to multiply the two a's.
Yeah. So this becomes 4a squared. Okay? So when you multiply the top line, then the answer is going to be b squared, and then take away. Remember that when you do the difference of two squared, it's always something square and then take away. Okay, that's why we have that take away in front of the bracket. Okay, so say it again. If you multiply the top line, then we have b squared minus in bracket b squared minus 4ac. And then when you multiply the denominator, then you're going to have 2a multiplied by 2a, so the answer is going to be 4a squared, right? Okay, but now let's simplify. So we're going to do b squared minus b squared plus 4ac all over 4a squared. Okay, and then you can see that the b squared, they cancel each other. Okay, so we're going to have only 4ac over 4a squared. And then you simplify this fraction, then the answer is going to be c on a. Okay, so that is going to be c on a. That's it. Okay, so conclusion. So therefore, we're going to say that when we have an equation like this, the relationship between the solution and the coefficient are, so therefore we're going to say alpha plus beta is equal to minus b on a, and alpha times beta is equal to c on a. And this is going to be extremely important. All right, so that is the conclusion when you have a quadratic polynomial. Okay, now we're going to study what happens when you have a cubic, and then what happens when you have a quartic. And in extension 1, we can go only up to a quartic. Okay, we cannot manipulate equation of 5 degree or 5th degree, I should say. Okay, so in extension, we can do everything, including the quartic, but nothing else. All right, so let's say this. All right, let's say that now we have a cubic equation. And you know that cubic equation looks like this. ax cubed plus bx squared plus cx plus d equal 0. And we expect to have 3 roots. So that means that this time we're going to have alpha, beta, and gamma. All right? We're going to say cubic. Okay, let's put cubic. Okay, let alpha, beta, gamma be the roots of this equation. All right, let alpha, beta, gamma be the roots of this equation. In the same way as we saw that there is a relationship between alpha, beta when you have a yeah, but I'm talking about this. Okay, in the same way as we saw that we have a relationship between alpha, beta, and this coefficient, okay, we're going to say that there is a relationship between alpha, beta, and gamma.
That's delta.
True. Alpha, beta, and gamma. There is a relationship between alpha, beta, and gamma, and this A, B, C, and D. Can you see that this time we have 1, 2, 3, and 4 coefficients, including the constant? Okay, now, then we have all right. We have the alpha plus beta plus gamma. Alpha plus beta plus gamma is equal to what we had before, so it's still equal to minus b on a minus b on A. Okay, so this is happening when you take the root one at a time. And then when you take the root two at a time, what I mean is alpha beta plus alpha gamma plus beta gamma. And then what is the other one? So we have alpha beta, alpha gamma, beta gamma. Do we have any other?
No.
Okay. Okay, so when you take them two at a time, then the answer still is going to be C on A. And then when you multiply them, when you multiply alpha, multiply by beta, and then multiply by gamma, then the answer is going to be at the new polynomial, so it's going to be minus D on A. Okay, so that is the relationship between the root and the coefficient. Now, I want you to look very, very careful. Can you see that in all these cases we are dividing by the leading coefficient? So it's always divided by A. So then it's easy to remember. And also, this negative will alternate. Okay, so it's going to be negative, positive, negative. Can you see that? And it's going to be B, C, D. All right, so there is a pattern there. Okay, so you start with the leading terms. You can say A, B, C, D. And then you can see that these negative are alternating. Okay, starting from a negative. Okay, so it's going to be negative, positive, negative. All right? And then you're going to see that for the quartic, that is going to be the last one that we're going to be doing. We're going to follow the same pattern. Can you see that if we have a quartic, then we're going to have another polynomial? So we're going to have E. Okay, so and then we're going to have, when you add them all together, we're going to have 4. So we're going to have alpha, beta, gamma, and delta. And then if you plus them all together, then the answer is going to be minus B on A. And then when you take them in pairs, then you're going to have the same thing. And then we're going to take them 3 at a time. And then we're going to take them, like this. Okay, but I'm going to write it down. Okay, and we're going to follow exactly the same pattern. All right? Okay, so this is another thing that you're going to have to remember, because later we're going to start doing some application to see what is the fussy about this stuff. Okay, so how are we going to use it? Does it make any sense? Is it worthy to know this? All right, so we're going to see why we are doing it. Okay? Yes?
Does that mean you could like do what we do for the quadratic and do like if you find a number that you can, or 3 numbers that you can plus together to equal the E, and then find that, and when they're multiplied in their pairs, they equal C, then when they're all multiplied, they just equal D.
Yes. Yeah, exactly right. Okay, so
Factorize the cubic.
yeah. Okay, so I mean that you're gonna be able to do this. So I'm gonna give you the solution. I'm gonna give you the 3 solutions of a cubic equation, and then you're gonna be able to create the equation, and you're gonna say, okay, this solution coming from this equation. All right? Okay, and then you're going to see that there are obviously some other application about this stuff, right? Okay, but that is what is basically happening. Okay, so you're going to give them the solution, and then you're going to have to create the equation. So you're going to tell me where we got the solution from. Okay, so we're going to study the relationship between coefficient and roots for a quartic now. Okay, so for a quartic, okay, when you have a quartic looks like this one. So we're going to have ax to the power of 4 plus bx cubed plus cx squared plus dx and then plus e equal 0. Okay, so that is a complete QWERTY equation. So we have all the terms there, nothing is missing, it's all good. And because it's to the power of 4, then we expect 4 solutions. Okay, and we're going to call the solution alpha, beta, gamma, and delta, all right? Okay, so we're going to say let alpha, comma, beta, comma, gamma, comma, delta be the roots of this equation. Okay, then we have okay, now we're going to be careful. So we have alpha plus beta plus gamma plus delta. When you write this, we're going to be careful because sometimes, the delta and gamma look similar. Okay? So delta and gamma looks similar sometimes. So you've got to be careful. Okay, so we got this is going to be equal to minus b on a. So that doesn't change. And then we're going to take them 2 at a time. And I'm going to write it down. So we got alpha, beta, plus alpha, gamma, plus alpha, delta, and then plus beta, gamma, plus beta, delta, plus gamma, delta, and that is going to be equal to C on A and then we're going to write down what happened when we take 3 at a time. Okay, so it's alpha, beta, gamma plus alpha, beta, delta plus alpha, gamma, delta plus beta, gamma, delta, and that is going to be minus d on A. And finally, alpha, beta, gamma, delta, that is going to be equal to E on A. All right. Okay, so this is another thing that you're going to have to remember, okay? So you're going to have alpha, beta, gamma, and delta, and then you're going to have to take them, 2 at a time, and then 3 at a time, and then when you put them all together. Okay, and then you can see the pattern. Okay, so it's always over A, over A, over A, over A. And in here we got B, C, D, and E. And the negative alternate. So we have negative, positive, negative, positive. Right? Okay, now we're going to see some simple application to start with. And then we're going to start doing some other stuff. All right. Now, let's see how we're going to be using this. And please don't get intimidating with the alpha, beta, gamma stuff, all right? Because the alpha, beta, gamma are simply, the solution for the equation. Okay, when I say alpha and beta, yeah, alpha, beta, you say, yeah, sound so mathematical, and yeah, some people don't like the alpha, beta stuff. Okay, but just think about, the solution of the equation. That's all what it is, all right? And when you see a lot of this writing here at the beginning, yeah, it's a little bit hard to write it down. But then when you get familiar, then you can do this very, very quickly. Okay, especially this one. Okay, this one is the easy one, and this is the one that appears most of the time in test. Okay, together with this. Very rarely this one. Okay, this is not very common in test because it's time consuming, and we are aware of that, right? So if you can do this and this, we are more than happy because that show us that you understand, what is going on. Okay, in my opinion, it's pointless to do this one in test. It's dead. I honestly wouldn't put any question using the quoting, except for something very, very special. But this one and this one are the one that you need to remember. All right, very, very well. Okay, we're going to say application. Yep. Sorry?
Does anyone have roll call in this room? Probably.
Yeah, I have roll call in this room.
You do?
Yeah.
That's why we're in here.
Are you here after?
Yeah, we have maths first.
Oh, yeah. Yeah, you can leave your stuff there, but yeah, it's not many people in. Yeah. Okay, so application. Okay, now we're gonna see how we're gonna do this stuff. Okay, so the first application is this one. If alpha, comma, beta and gamma are the roots of 2x cubed minus 6x squared plus x plus 2 equals 0. Find the value of number 1, alpha plus beta plus gamma. So we need to find the answer for that. 2, alpha beta plus alpha gamma plus beta. Yeah. So we got alpha beta.
So you just have beta gamma.
Yeah, beta gamma, and then plus gamma and alpha. So that's it, alpha gamma. So we need to find the answer for that. And 3 alpha beta gamma. And then we're going to have another one. I want you to find this alpha minus 1, beta minus 1, and then gamma minus 1. All right. And this is a classic question in test. It's just to see whether you remember the relationship between the roots and coefficients. All right, so then you say solution. Okay, so we know that when you do the alpha plus beta plus gamma, regardless of what the polynomial is always equal to minus b on a. All right? And we know that b is equal to minus 6 and a is equal to 2. So we're going to do minus 6 on 2. So that will give you positive 6 divided by 2. So that means that the answer is going to be 3. Okay? So the answer for this is 3. All right? Am I going too fast? Yeah. Okay, so we know that when you plus them together, Okay, we know that when you plus them together, the answer is always minus b over a. Okay, and here we have that this is a, this is b, c, and d. Okay, so we should do minus minus b on 2. Okay, but we know that the answer for that is equal to 3. All right? Okay, so that is the first part. And the rules say that if you take them in pairs, so if you take alpha, beta, plus beta, gamma, plus alpha, gamma, so if you take them 2 at a time, the answer is equal to c always over a. Okay, so c in this case is equal to positive 1 over a, so it's going to be a half, right?
Yeah.
So it's going to be 1 on 2. Right, and also we know that when you times them together, when you times, all the roots together, alpha, beta, gamma, we know that that is going to be equal to minus d on a. Okay, so this is d. Okay, so we got a, b, c, d on a. So it's minus d on a. So it's going to be minus 2 on 2, and that will give you equal to negative 1. All right? Okay.
It's D. It's C on A.
No, no, no. No, it's d. D. All right. And then what else? Okay, and then question 4. Okay, question 4, we have something that we don't have any special rule. Okay, so we know this. We know that what happened when you add them all together. We know what happened when you take them 2 at a time. And we know what happened when you multiply them. Okay, but in this question, they're asking you to find the answer for this. Okay. Most of the time when you are asked to find something new, when you're finding something new like this, it is very likely that you're going to be using some of this result in this expression. Okay, but so what we are going to do, we are going to multiply this. Okay, so we're going to have to multiply these factors, remove the bracket, and then probably it's very likely that we're going to have something like this or like this, I don't know. Okay, but let's multiply. Okay, so we're going to multiply these 2 first, and then we're going to multiply the answer by the 3rd, all right? Okay, let's multiply these 2 first. So it's going to be alpha times beta. So we're going to say alpha, beta. And then we're going to have negative alpha, because it's going to be alpha times negative 1. So it's going to be minus alpha. Okay, and then we're going to multiply negative 1 times beta, which is minus beta. Okay, and then negative 1 times negative 1, which is 1. All right? Okay, and then we're going to have to multiply that by the next factor. Okay, so we're going to have to multiply all this by this. Okay, and now is just about algebra. So we're going to have to multiply this very, very carefully without making mistake. All right. So the first one will give you alpha, beta, and gamma. Right? Okay. So alpha, beta, and gamma. And then we're going to have alpha, beta multiplied by negative 1. So it's going to be minus alpha, beta. All right? Okay, and then we're going to move on to negative alpha. So we're going to multiply negative alpha times gamma. So it's going to be minus alpha gamma. And then negative alpha times negative 1. So it's going to be plus alpha. All right, and then we finish with the alpha. So we're going to move on to negative beta. Okay, so negative beta times gamma. So it's going to be minus beta gamma. And then negative beta times negative 1, so it's going to be plus beta. Okay, and then we have the last one, which is positive 1. So if I multiply positive 1 times this, it's going to be plus gamma, and then minus 1. Okay, but then if you look carefully, we already know the answer for this. Okay? Is equal to negative 1. Okay, so I'm going to put negative 1. And in here, can you see that we have alpha, beta, and gamma? Can you see that we have alpha, beta, and gamma, and that is equal to, what is it? 3? Okay, so we're going to put plus 3. And then can you see that we have the one that are taken 2 at a time? So we're going to put I'm going to put negative bracket alpha beta plus beta gamma plus alpha gamma. And then don't forget the one, don't forget the one at the end. All right, but we know that this is equal to half. Okay, so that is equal to half. Okay, and then you can put all the answer in your calculator, and that's it. That will give you the answer for this unknown thing. The answer is half. Yeah. All right? If the question is about finding this, and this, is easy, because we know what they are equal to. But sometimes, in addition to this, you're going to have to calculate another one. But 99.9% of the time, this is coming from a combination of these two things, or three things in this case. Okay, but that's all what it is. All right. Okay, so this is only one application of what we've done before. Okay, but there are obviously many more and different ones. Okay, so we're going to finish in here. That was the introduction. And then make sure that you go through these pages, get familiar with some of the questions. So you should just read, okay, just read through page 225, and then we're going to start doing the exercises from 28.6. Okay, but for now, all what I want from you is to read, the rest of page 225. All right? Okay, so you can stop the video now.